Good morning, Year 9s. We're going to look today at cables and plugs. We're going to identify the wires in a plug. We're going to look at the difference between a 3-prong and a 2-prong plug and recognize different safety hazards when dealing with electricity, fuses and double insulation. So put a heading in your book, Cables and Plugs, and today's date. To do the now activity, do now. From last week you should remember what is the frequency in the UK home, potential difference in UK homes, and can you draw a graph to show direct and alternating current? What do you remember? And going back, retrieval, you remember 8 stores of energy. Pause the video and do this. Right, so you should know that the frequency in a UK home is 50 Hertz. You should know the potential difference in the UK home is using 230 volts. Remember, alternating current goes up and down. It goes from negative to positive. And direct current is just a straight line graph, a flat line. And then your 8 stores of energy. Do you remember them? Okay, so we've got 8 kilograms of cement. So there's 8 stores. K standing for kinetic, G gravitational, C chemical energy, elastic, mechanical, electrical, nuclear and thermal. So I don't know how you did. Mark your work. I will continue. Right. Alternating current. Remember, alternating current goes from positive to negative. So an advantage, a good thing about that, is that it can be increased. We can increase that energy, or we can decrease it. It can be stepped up or stepped down. You find a transformer that actually undergoes this process, causing the voltage to increase or decrease. And it's very handy when you need to transmit electricity over long distances, all the way from the nuclear power station or the electrical power station to your home. And it's very efficient. So can you write 2 examples of why alternating current is very handy? Write that in your book, please. Pause the video. So how does alternating current occur? What really happens is that a loop of wire is spinning within a magnetic field. If you think of a vehicle that gets started, there is a battery to send out a charge, but there must be something that helps to create this alternating current in a vehicle. So you've got a generator that has some kind of power source to send the energy through the loop or through the circuit, and then there'll be 2 magnets with a north pole and south pole, and it causes this to spin. When we're back in class, we'll do a practical on this. It means that the electric charges can keep spinning. If we change these connections around, it might rotate clockwise or it might rotate anti-clockwise. So depending on how we've connected these 2 connections here. Right, just some quick things to look at. Can you identify about 5 dangers or 5 hazards of electricity, how people are using it? Pause the video, write down 5 things that you see. Alright, so you're back. This guy has got the toaster plugged in. He's putting some kind of metal object in it. You could get electrocuted. The wires on the floor could be a big tripping hazard, very dangerous. This young lady here is poking into the electric circuit or socket with a piece of tool here, metal tool. Water from this pot plant becomes a big danger, and it's by the computer and the keyboard. This girl's got her coffee here, also liquid hazard. And then this plug is still plugged into the kettle while this girl is busy filling it with water, very dangerous. And then of course the circuit board is left open and exposed, and it should be closed at all times. So there's definitely more than like 5 safety hazards. Suggest some precautions. Well, you should tape or not have wires on the floor. Do not use metal objects in sockets. Switch off any appliance once you start to fill it with water. And keep water away from all electrical appliances. Right, so how can electricity be used safely? You should have written some of these down. You can pause the video. Yeah, this one has definitely overloaded this socket and could be a fire hazard as well. So you can write some of these down. Right, we're looking at a UK plug. Most plugs have a 3-pin plug, which means they have 3 extensions from it. And then within the plug, it's properly sealed, but inside we have a fuse. The fuse will control the amount of electricity that flows. You have an earth terminal. An earth terminal is like a neutral charge. It does not, it actually, in case of any danger, it will help reduce that danger. We have a neutral terminal, and then we have a live one, and the live one could be red or brown, and the neutral is blue. So there's a lot of safety features within the plug. The plug itself is plastic, which is a non-conductor. The fuse will help control how much potential difference is released. It can reduce the charge, and there's an earth wire which also will neutralize the charge should something go wrong. So going back there, you should have an attachment of a plug. You're going to look at these different plugs and you're going to identify what makes them unsafe. So just a clue here, we have 2 wires of the same color. Over here, I think there's a bit of exposed wire. This plug has got a big chip out of it. Why is that dangerous? And so you'll complete that in your book, what needs to be done. Remember, it should have a live wire going to the right, neutral to the left, and an earth wire going to the top pin. So the only charge that should be flowing is through the live wire, and the fuse, as I said, reduces the charge. It controls it. Right, why is electricity dangerous? Well, current passes through the material and it could result in an electric shock, electrocution, and some of it's so dangerous it could kill. So you might want to draw this triangle, and you can draw this arrow in here to show that this means danger, electrical danger. Right, so going through the parts of the wire that's colored in green is connected to the very top of the plug, the northernmost part of the plug, and that is called an earth. E stands for earth. Then going to the left is a blue wire, and it must always be connected to the left, and it is neutral. And then the wire that is brown, this is a live wire, this is where the charge is flowing. Could you now draw a table, list the colors in that table and of the wires, and then just write down what they stand for. What do they represent, those different colors in the wire? So you're drawing a table now in your book, bigger one than this, and you're listing the different colors and what they stand for. So you'll have alternating currents that goes towards a plug in a domestic home, and you'll have these three wires. The yellow one goes all the way to the top, the red, the blue, the brown one to the left, the blue to the right. So you're drawing your table, you're listing the different colors. Blue, what are they called? Brown, and yellow and green. So the electrical cables contain three wires. They're all made up of copper. Copper is a very good conductor. Covering that on the outside is plastic, which is insulating, stops the electricity, these wires connecting and becoming dangerous, and they're quite flexible. And then overall, around all three different colored wires is an electric, an insulating cable, and that's what it looks like. Right, so just to remember, neutral has 0 voltage. The earth wire is safety. If there develops a fault, then this will automatically cause this electricity to switch off or trip. And then the live wires, it alternates between positive and negative, that being the AC current alternator. So you can see many cables or copper wires inside here. What is an electrical socket? Those are the things you find in the walls of your home where you plug in your electric appliances. So it connects plugs, and we call that the main electricity system. This electricity has come all the way from a power station, and in our homes 230 volts. So can you just write a sentence about what an electrical socket is? How do plugs and sockets carry current? First of all, there's a switch here, so you can switch on and off the current. The pins themselves are made up of brass. They're good conductors. It's a very hard metal, so the wire won't heat up too quickly, or the metal of the pin, these extensions here, and they won't bend, which is a good thing. Right, you need to write down these different parts of a plug. What is the case made out of, and why is it made out of, for example, plastic? Is it a good or a bad conductor? What are the pins made out of, and what are the wires made out of? Can you do this in your book? Pause the video. Okay, so going back, Just to show you, the casing is made up of plastic and it is a non-insulator. It is an insulator, sorry. The wires inside the cables are made up of copper, very good insulators, conductors. And then the pins are brass. Remember we said that these pins are made up of brass. They're good conductors, they're hard, and they will not bend. So you should have written that all in your table. Just do your corrections, pause the video. Right, so how do we wire a plug? Remembering that blue is neutral. We cannot have any loose wires in here. They all need to be sealed with this plastic covering, and they should not be connecting to each other, because that could cause a circuit or a charge, a high charge. So there's no loose bare wires. The grip should firmly hold the cable, so all these screws are firmly holding the cable down. And the correct value, all these fuses have a certain amp, a number of currents that flow through them. So you need the correct fuse. If it's too high or too low, the appliance might blow or it might not work. Please can you write these 3 facts down about wiring a plug, safety features. So just to check, what color wire goes this way to the left, which color wire goes to the right. And please note it's near this fuse. This fuse here in this appliance, for example, is 13 amps. And then what color wire goes on top there. Remembering it has insulation around it. Another safety feature, you can switch it on or off the plug at the main socket. You can draw the plug and label it, or you might have a diagram that you can label. And then what happens to the fuse? The fuse must be in the live wire so that the appliance becomes disconnected. If the value is higher than the normal working current, it can be easily replaced. So, true or false? Can you answer these? 6-question quiz. The live wire is brown. Number 2, the earth is blue. Neutral wire is blue. So they can't both be blue. One of them has to be incorrect. Is it safe to remove the insulating plastic? What do you think? An appliance only requires a live wire and an earth wire. True or false? And the cable grip stops the cable from pulling out. So what is the cable grip? It's this thing. The screw that holds it down. What do you think? Pause the video and answer those questions. Right, we're talking about earthing now. Put a heading earthing. It's the process used to increase the safety of any appliance. Now remember, in the plug there's a live, a neutral and an earth wire. So that yellow-green cable is the earth. It's an alternative path for current should a fault develop in the appliance. And that means that once the current runs into the earth, it really goes nowhere, so therefore the electricity can stop flowing. Can you write a definition for earthing? One thing to note, when an appliance is working correctly, no earth is required. Pause the video, define the word earthing. Another type of plug we get has got 2 pins. You might have a hairdryer or a smaller appliance with 2 pins. Now remember, there were 3 pins. Normally in a 3-pin there's yellow and green combination, a brown and a blue wire. So in the 2 plug, what is missing is one of those. Some sockets in Europe have 2 slots for 2 pins, and instead of having a pin for the earth connection, the plug has a clip on the side. So here is the clip. So there's no earth connection in a 2-prong plug. Can you write an example and define what is a 2-pin plug? If something is double insulated, so this is a safety feature. What does that mean? Double insulated appliances have plastic cases without any wires connected to the case. The case cannot become live. Plastic does not conduct electricity. So basically, double insulation. It has a plastic case without any wires connected. Can you write a definition for double insulation? Pause the video. Right, so here are some questions again. What do we remember? An earth wire carries a current to the appliance. What is the live wire? Is it earth? No. All UK plugs must have a fuse. What do you think, if it's a safety feature? Any earth wire and fuse protect the user from all risk. An earth and a fuse. Sounds good. Double insulation do not need a fuse. Just go back quickly. Double insulation appliances without any wires connecting to the case, and this means that the plastic does not conduct electricity. Does it say anything about fuse? Don't think so. Fuses protect electrical cables from danger, not the cable itself. And if too high a current flows through the circuit, the fuse will blow. Pause the video, do these 6 questions now, please. Okay, going back to our first set of questions. A live wire is coloured brown. No, it's yellow and green. An earth wire is blue. Sorry, a live wire is brown. This is correct, sorry. And an earth wire is yellow and green, so this is false. Neutral is blue, correct. It is safe to remove the insulating coat from the earth wire. I wouldn't recommend it, no, because this needs to actually run out of charge or actually stop the electricity flow, so it needs to still be insulated. An appliance only requires a live wire and an earth wire to work safely. No. Remember, there's fuses as well, and it needs some kind of insulation around the cables. A cable grip stops the cable from being pulled out, correct. And then the other set of questions, an earth wire carries current to an appliance, false. Remember, the earth wire causes the current to stop flowing. All UK plugs must have a fuse, yes. An earth wire and a fuse protect the user from risk of electrical shock, correct. Double insulation does not need a fuse, this is true. And fuses protect electrical cables from damage. No, it's the insulation that protects the cable. If a current that is too high flows through the circuit, the fuse will blow. Absolutely correct. How did you do? Right, we have some terms for you. An appliance that contains an internal insulation and a non-conducting case. What is that called? Can you write down these 5 terms and then try and write the correct word of what it means? Pause the video. And so, if there's internal insulation, that's called double insulation, a method of improving the safety of an appliance to provide low resistance. Earthing. An earth wire connects the metal case to the appliance to earth it. And then the danger from electricity could result in electric shock. Muscles could spasm and even cause a heart attack. And a fuse, a safety component to actually insulate the wire, preventing it from heating up. It will melt and blow if the current gets too hot. How did you do on these answers? Make sure that you go through these terms so that you understand the safety of electricity. Thank you.